You all. I am Dr. C. Jagan from Rogani College of Engineering and Technology, Associate Professor, Electronics and Communication Department. So this video I have discussed about ad hoc wireless sensor networks, satellite access, modulation and multiplexing, voice, data, and video. Communication satellites are used to carry telephone, video, and data signals and can use both analog and digital modulation techniques. Modulation, modification of a carrier's parameters, amplitude, frequency, phase, or a combination of them in dependence on the symbol to be sent. Multiplexing, task of multiplexing is to assign space, time, frequency, and code to each communication channel with a minimum of interference and the maximum of medium utilization. Communication channel refers to an association of senders, receivers that want to exchange data, one of several constellations of a carrier's parameters defined by the use modulation. Voice, data, video. The modulation and multiplexing techniques that were used at this time were analog adapted from the technology developed for the change to digital voice signals made it easier for long distance communication carriers to mix digital data and telephone fiber optic cable transmission standard system bitrate million bits per second 64 kilobits per second voice channel capacity. Stuffing bits and words are added to the satellite data stream as needed to fill empty bit and word spaces. Primarily, primarily for video provided that the satellite links overall carrier to noise but into older receiving equipments that system and satellite specification Q-band modulation and multiplexing. In analog television transmission by satellites, the baseband video signal and one or two audio subcarriers constitute a composite video signal. Digital modulation is obviously the modulation of choice for transmitting digital data or digitized analog signals may conveniently share a channel with the digital data, allowing a link to carry a varying mix of voice and data traffic. Digital signals from different channels are interleaved for transmission through time division multiplexing TDM carry any type of traffic. The bent pipe transponder that can carry voice, video, or data as the marketplace. Proximity, voice and data multiplexer and demultiplexer. Analog digital transmission system. Analog versus digital transmission compare at two levels. Data continuous audio versus discrete test signaling signaling continuously varying electromagnetic wave versus sequence of voltage pulses. Also transmit without regard to signal content versus being concerned with the signal content. Difference in how attenuation is handled, but not focus on the seeing a shift towards digital transmission despite large analog base. Basic communication systems block. Improving digital technology, data integrity, repeaters take out cumulative problems in transmission, can thus transmit longer distances, easier to multiply large channel capacities with the digital, easy to apply encryption to digital data, better integration if all signals are in one form, can integrate voice, video, and digital data analog signals must convert digital data to analog signal. Such device is a modem to translate between bit serial and modulated carrier signals. To send signal digital data using analog technology, the sender generates a carrier signal at some continuous tone. Example 1 to 2 kHz in phone circuits that looks like a sine wave. The following techniques are used to encode digital data into analog signals. Figure analog digital analog transmitter receiver resulting bandwidth is centered on the amplitude shift modulation keying. Vary the amplitude example voltage of the signal used to transmit digital data over optical fiber. Frequency shift modulation. Two or more turns are used which are near the carrier frequency used in full duplex modem signals in both directions. Phase shift modulation systematically shift the carrier wave at uniformly spaced intervals. For instance, the wave could be shifted by 45, 135, 225, 315 degree at each timing mark. In this case, each timing interval carries 2 bits of information. Why not shift by 0, 90, 180, 270? Shifting 0 degrees means no shift, and an extended set no shifts leads to clock synchronization. Frequency division multiplexing (FDM). Divide the frequency spectrum into smaller subchannels, giving each user exclusive subchannel. Example: radio and TV. One problem with FDM is that a user given all the frequency to use, and if the user has no data to send, bandwidth is wasted. It cannot be used by another user. Time division multiplexing is a time slicing to give each user the full bandwidth, but for only a fraction of a second at a time, analogous to time sharing in operating systems. Again, if the user does not have data to send during his time slice, the bandwidth is not used. Example: wasted. Statistical multiplexing allocate bandwidth to arriving packets or on demand. This leads to a most efficient use of channel bandwidth because it only carries useful data. That is, channel bandwidth is allocated to packets that are waiting for transmission, and a user generating no packets does not use any of the channel resources. Digital video broadcasting. Digital video broadcasting has become the synonym for digital television and for data broadcasting worldwide. Digital video broadcasting services have recently been introduced in Europe, in North and South America, in Asia, Africa, and Australia. This article aims to describe the digital video broadcasting is all about and at introducing some of the technical background of a technology that makes possible the digital video broadcasting configuration.